You know that feeling when an app is just instant? Well, the secret behind that magic is a trick called caching. But here's the thing. For the folks building these apps, there's a huge decision to make. It's a real developer's dilemma. So today, we're going to break down the two big players, in-memory and distributed caching, and figure out how they deliver that snappy performance we all love. Let's dive in. Oh yeah, we've all been there, right? Staring at that dreaded loading spinner, just waiting, that little moment of frustration. That's exactly why every single millisecond matters. In the world of software today, speed isn't just a feature, it's everything. And caching, that's our #1 weapon in the war against waiting. Okay, so here's the game plan. We'll start with the problem itself, then we'll put these two caching types to the test with a food delivery app. After that, we'll see how it all works in the real world, and I'll give you a super simple way to remember it all. Sound good?
All right, first up, the millisecond challenge. So, what's the actual problem we're trying to solve here? Well, deep inside almost every app is a database. Think of it as the big, reliable library. It's fantastic for keeping everything safe, but man, is it slow to get a book from. Every single time our app needs to ask the database for something, it's like a long walk to the back of the library. That trip costs time, and when lots of people are making that trip at once, you get a massive performance bottleneck.
And that's where caching swoops in to save the day. The whole idea is ridiculously simple but brilliant. Instead of making that long, expensive trip to the database every single time, we just keep a copy of the stuff we use all the time in a super fast, easy-to-reach spot. It's basically a high-speed shortcut, letting us skip the long walk to the back of the library entirely. Okay, so once a developer says, yep, we need a cache, they hit a major fork in the road. This is the big dilemma. It's not really a question of if you should cache, you pretty much have to. The real question is how. And this one decision can make or break an app's performance and its ability to grow.
And here it is, the big question. Should I use an in-memory cache or a distributed cache? I mean, should this fast shortcut live right inside the app itself in its own memory? Or should it be a separate shared resource that all parts of the system can access? Both ways have some serious pros, and that, my friends, is the dilemma.
So let's break that down. On one side, you've got the in-memory cache. Its core strength, blazing, incredible speed. On the other side, you have the distributed cache. Its superpower, it's shared, and it can scale like crazy. It really is a classic showdown. Pure, raw speed versus a system that's built to share and grow.
All right, enough with the theory. Let's make this real. We're going to run a little experiment, the food delivery test. We'll use a food delivery app, something we all get, to see how these two caching strategies handle two totally different kinds of problems.
Okay, problem number 1. Imagine you're serving up millions and millions of restaurant menus. The thing is, the menus are pretty much identical for everyone, and they don't change very often, right? In engineer speak, we'd call this hot static data. So, what's the absolute fastest way to get that menu to a hungry customer?
Well, for this job, an in-memory cache is the perfect tool. Here's how it works. A request for a menu comes in. The app first checks its own back pocket, its super fast local memory. If it's there, bam! That's a cache hit and the menu is sent back instantly. If it's not there, that's a cache miss, no big deal. The app just takes one trip to the database, grabs the menu, and then, here's the key, it saves a copy in its memory for the next time someone asks. So, the pros and cons here are super clear. The pro? It is lightning fast. I mean, there's no network call, it's right there. Plus, it's pretty simple to set up. But the cons? They're pretty big. See, that data only lives on one server. So if you have multiple servers, they can get out of sync. And the real kicker? If that server restarts for any reason, poof, the cache is completely gone. Okay, now for problem number 2. Let's talk about a user's shopping cart. This is the complete opposite of a static menu. A shopping cart is totally unique to you. It's changing all the time as you add or remove items, and this is critical. It has to be the same no matter which of the company's servers your phone happens to connect to.
For a job like this, the in-memory cache just won't cut it. We need a distributed cache. The process looks kind of similar at first, but there's one massive difference. The app doesn't check its own memory. Instead, it makes a quick network call out to a separate, shared cache. Think of it like a central hub that all the servers can talk to. This shared cache becomes the single source of truth, making sure your shopping cart is always there and always correct, no matter what.
And when you look at the pros and cons here, it's all about reliability and scale. The big win is that your data is shared everywhere, nice and consistent. And if one app server crashes, no problem. The cache is still safe and sound. The trade-off, well, it's a tiny bit slower because of that network hop, and you do have to set up and manage this whole separate system, which takes some work.
So, this whole idea isn't just for a little food delivery app. This pattern, using both kinds of caches, is a standard battle-tested playbook. You'll find it pretty much everywhere, in any big industry that needs to be fast and reliable at a huge scale.
And yeah, you see this pattern playing out all over the place. Think about e-commerce. The product catalog that everyone sees, that's probably in memory for speed. But your personal shopping cart, that's in a distributed cache. Banking apps, same deal. The latest currency exchange rates might be in memory, but your transaction history is definitely in a shared distributed system. The rule is always the same: in memory for fast, public data, distributed for personal, dynamic data.
By now, you've probably figured out where this is going. The answer to that big developer's dilemma, it's not either or. The real professional-grade solution is to think both and. You use both of them strategically.
So, any serious real-world system is going to be a hybrid. It's about using both caches for what they're good at. You also have to be smart about it. You set rules so old data gets cleared out. You focus your energy on caching the stuff that gets hit the most. And maybe most important of all, you have a backup plan. What happens if the cache goes down? A good app doesn't just crash, it knows the fallback to the slower database instead.
And really, that's the key takeaway here. This isn't a competition between the two. Real-world systems combine both. You use in-memory for that raw speed, and you use distributed for scale and reliability. It's just about using the right tool for the right job.
All right, to make sure this really sinks in, I've got one last thing for you. A simple mental model, an analogy that will make this all click into place.
Just think of it like this. The in-memory cache, that's your desk drawer. It's right there, super fast to grab a pen from, but it's your drawer. It's only for you. The distributed cache, that's the big office filing cabinet. Yeah, you got to get up and walk over to it, so it's a bit slower, but it's the shared, reliable spot where the whole team keeps the important stuff.
And it just makes sense, right? You wouldn't keep the official company blueprints in your personal desk drawer, and you're not going to walk all the way to the main office cabinet every time you need a paper clip. You use the right tool for the job. And that's exactly how smart caching works. So, at the end of the day, the answer is 2 caches. It's not about finding one perfect cache that does everything. It's about using 2 different tools that work together beautifully. And honestly, This hybrid approach, it's the secret sauce behind almost every fast, reliable app you use.
So I'll leave you with a question. Now that you know this pattern, this trade-off between local speed and shared scale, start looking for it. The next time you're ordering food or shopping online or streaming a movie, where do you see this clever two-cache system working behind the scenes? Thanks for joining me.